All right, let's go over the graphing part. So the learning objective 3, graphing logarithmic functions. And we will also look at finding domain of a logarithmic function algebraically, okay? I think we can cover the rest of them too. Finding the domain, range, asymptote, and just one simple application, one single application problem. So the goal is to go over page 3, 4, and 5 in this video. Please check the first part for page 1 and 2. And after finishing all these notes, I will show you where you can find your 3.3 daily problem, okay? Alrighty, let's get started on the graphs of exponential and logarithmic functions. Now, last lesson, when we did 3.2, I mean, you already kind of got this. You understand, you know about the exponential functions and their graphs. A couple things that we talked about were that the domain of an exponential function was always all real, while the range, though, range was from 0 to positive infinity because I guess one of the example that we went over was 2 to the x power or 1/2 to the x power. The idea was you keep on taking half of half of half of half, and it will never get to 0. It's going to get really, really close to 0. So the range was from 0 to positive infinity before we do any kind of vertical translation, right? We also had a horizontal asymptote at y equals 0 before we moved it up or down at all. If you have to move it up or down, these two, range and the horizontal asymptote, really changed, right? It passed through 0, 1. If b was greater than 1, the function was increasing. If b was in between 0 and 1, like a fraction value, 3/4 or 0.25 or, any of those, then the function was decreasing and we call them exponential decay. So check out the 3.2 lesson video if you need a little more review of that. But today, let's focus on the graph of the logarithmic function. Now notice this for me. The domain of an exponential function, which used to be negative infinity to positive infinity, all real, is now the range of the logarithmic function. Why? Because, guys, these are inverse functions. So to write the inverse function, you switch x and y. So their domains and ranges are going to be switched. So the range of the exponential function, the 0 to positive infinity, is now 0 to the domain of a logarithmic function. Now, of course, these will change. Remember, when we have a vertical translation in exponential functions, the range changed, right? Now, if we have a horizontal translation in a logarithmic function, the domain will change. And we will look at how to find these domains algebraically on page 4. But just kind of wanted to show you how they're very similar. Like, for example, we had a horizontal asymptote at y equals 0 for a exponential function, right? But now we have a vertical asymptote at x equals 0 for the logarithmic function. It's very, very similar. But you know what? Let's actually get to graphing one of each on a single graph so that we can see they are inverse of each other, okay? Now, I picked two functions for you. F of x is 2 to the x power. That's an exponential function, right? And the other one is g of x equals log base 2 of x. So we're going to graph these two in a single graph, and we'll identify the domain and range, okay? So the first one, let's work with the exponential function that we did in lesson 3.2. You're raising 2 to the x power. So if I'm doing the easier ones first, 2 to the first power is just 2. 2 squared is going to be 4. 2 to the third power is 8. Now, these ones are just simple, raising 2 to a single number. But what about 2 to the 0 power? Anything to the 0 power is 1. Now, what about 2 to the negative first power? That's going to give you 1/2. So that's going to be 0.5. I'll plot 0.5 over there, okay? Or let me write it as 1/2. I just noticed something. All right, I'm going to graph these right now, okay? -1, 1/2 right here. -1, 1/2 right there. Next one. What's the next one? 0, 1. 0, 1's right here. Oh, that looks like the y-intercept. Next one, 1, 2. Look, it curves up. It's going up. It's an increasing function. 2, 4. You know why this is an exponential growth function? Because what was the base? Base was 2. It was greater than 1. Therefore, it's a growth function. 3 and 8. It curved up pretty high. Now, what will be the next point? 4, 16, right? That's going to be a big number. Now I'm going to go ahead and graph these lines. Maybe use this yellow highlighter. So it's going to go up like crazy to the right end, but to the left end, what will it do? You keep taking half and half and half, you're going to approach the horizontal asymptote of y equals 0. But it will never cross down to the negative side. Let's write the domain and range of this. Remember that the domain of an exponential function is always all real, right? Negative infinity to positive infinity. Now the range though, you notice that it's gonna go up like crazy to the right. So yes, it will go up to positive infinity, but you know, as you keep on, look at the left tail, it's going to 0. It's not gonna approach, it's not gonna touch 0, but it's approaching 0. And that's what horizontal asymptote, how you know the horizontal asymptote is defined as x approaches either positive or negative infinity, y value is approaching this value, and in this case that will be 0. Now I'm gonna go ahead and do the logarithmic, but remember I said they are inverse functions, but you know, let's not use that, because what we can do is this. Listen, I can just look at these points. 0, 1 is the order pair for the log exponential function. So what I know is I better have a point at 1, 0. If I have 1, 2, then I better have a point at 2, 1. You see what I mean? And then the next one, 2, 4. If I have an x value of 2, y value of 4, the inverse function will have 4, 2. Now, but I want to test that. I want to actually get the table and show you that the x and y value switched, because that's how you write the inverse functions, right? So let's focus on working with this logarithmic function this time, okay? So let's go, I'm gonna use a red pen for this one. How about we find log base 2 of 1 first? What's that going to be? This is a question, if you try to say it in word, it's gonna go like this. 2 to the what power will give you 1. 2 raised to the what power will give you 1. And you know, anything raised to the 0 power is 1. So I know the answer is 0, but since we are very new to log altogether, we can type this in our calculator. We can type in log base, where's my log base? 2 and 1. Right? And that if you type that in, you will get 0. So it's okay if you want to use your log base function in your graphing calculator to evaluate these log function. Log base 2 of 2 will be 1. But just like that, you want to evaluate a couple of these logs so that we can plot the points. Oh, not a regular log though, right? We need math, log base 2, and the next number is 3. So if I plug in 1, 2, and 3, oh, whoopsie, it's not 3. I think it was 4. That's not a nice point to plot. So I think I skipped that in my XY table when I made it. But let me go back. So, you know, you'll have your calculator right next to you, but I just can't open two screens. Maybe there is a way for me to open two screens. But I'm just going to go ahead and go fill out this table. But I know you do have the tool to evaluate these. Log base 2 of 2 is 1. What's next? Log base 2 of 4. Now, that's the easy one to think about, right? 2 to the what power is 4. 2 squared is 4. Next one, 2 log base 2 of 8 equals. Now, 2 to the third power is 8. So we know that's true there. Now, the last one that I skipped. What is log base 2 of 1/2? What do you have to raise 2 to so that we get a 1/2? Well, the answer will be -1. 2 to the negative first power is 1/2. So we know that's going to be -1/2. Now, by evaluating these log expressions, we filled out this XY table. But I want you to notice this now. As you can see, the XYs are switched. The easy ones that you can see are 3, 8. That changed to what? 8, 3. 2, 4 is now 4, 2 in our log function. 1, 2 is 2, 1. Do you see how the log function and inverse function with the base of 2, they are inverse of each other? So let's write the domain and range. Domain, well, remember, they're inverse of each other. You know what? Let me go ahead and graph it. Let me go ahead and graph it first. half to the right, down 1. Half to the right, down 1. Over here. What's next? 1 to the right, 0 up or down. Next, 2 to the right, up 1. 4 to the right, up 2. And lastly, my last point is 8 to the right, up 3. Now, let me connect these with the line, or with the curve. Go up that way. But remember, we have a vertical asymptote at x equals 0. So the domain for this logarithmic function is from 0 to positive infinity, which is the range for the exponential function, right? Now the range is going to be all real, negative infinity to positive infinity. I know some of the graphing calculators, if you try to graph the log, it cuts off the tail that goes down. Let me check that over here too. Or maybe Desmos is my favorite graphing app. I'm going to go ahead and graph that log base 2 of x here. Y equals log base. I bet there is log here. Or maybe I can just type in log. Okay, I can. But then I don't know how to make the base. Functions. It says functions. That distributed miscellaneous. Oh, here it is. Log base 2. And then I will do x right there and I graph it. You see the graph? This is the graph that we just copied. This is a good app because sometimes when I graph my log function in a TI-84, it looks like they're cutting off the tail to the left. But you can see the graph is going to the right forever. But then the graph is not crossing this line of 0 to the left. So the domain is from 0 to positive infinity. But range, as you can see, this red line is going down forever. So this is a good app that I use to graph the log function. But many of the graphing calculators, they just... Let me try that over here, okay? What if I try log base 2 of x in this calculator? Will it graph it correctly? See? You see what's going on here? If I zoom in, it shows me the blue tail, right? It's going down, but at some point, it's just going to stop the blue line. But I need you to know that it's going to go down forever. It's not going to stop in the middle of it, okay? Alrighty. So that's how we can graph the log and the exponential function. And the reason I kind of wanted to do it on the same line was because, do you see? I'm drawing the line y equals x. Do you see that these two graphs are symmetric with respect to the graph y equals x? And this is what inverse function graphs should look like. So if you graph another one, for example, if you said f of x equals 3 to the x power, and g of x equals, what will be the inverse of that, guys? Log base 3 of x. Something very similar will happen. And maybe I will ask you to do that on your exam 3. Graph both the exponential and logarithmic function in the same graph and talk about all these different parts. All right, but we graphed one by hand, but I do know that you got the graphing utility to help you with. Let's try this fun problem. Example 5, they want you to find the function of the form y equals log base a of x, whose graph is given. Now, we got a little problem because we don't know what the base is, and we just got a graph. So what we will need to do is figure out what that log base is. I'm going to highlight what we need to find. We need to find what this a is, okay? But here's the good news. We got this given. Now, whenever they give you these ordered pair, what are they giving you? They're giving you that the x is 9. And they're also telling you that the y value is 2. So I know 9 and 2 can be plugged in to my y equals log base a of x. Let's plug in x and y in here. Y is 2. Write down log base a. And then what's x value? X is 9. Now, and you may wonder, how do I undo this log base a? I mean, what can I do so that the log is not there anymore? So what we're going to do is at this point, we're going to write this as an exponential form. So write this in, rewrite in what form? Exponential form. Let's do that. What is the base? Base is a, right? A to the what power? second power, right, equals 9, right? So what we just used, we used the definition of log to rewrite this as an exponential form. What we did in the very first video, we know this orange box is equal to the green box, so we just simply rewrote it. And sometimes when we rewrite things in a way that we are more familiar with, we can solve it. Because take a look. I think you know the answer to this question. A to the second power, or if you square this number a, you will get 9. If you want to solve for a, what will you do to both sides? What will be the math operation? You will take square root of both sides, right? Then you get a equals, now be honest with me, I know you usually just think 3. 3 is okay, but technically it should be plus or minus 3, right? But why are we going to throw out negative 3? Why is the correct answer only positive 3, not negative? Because remember, in the very first video that we mentioned, take a look at this part for me. The base has to be greater than 0. So we're not going to accept the negative log base, okay? That's why we throw out the negative 3. Otherwise, if you're just solving a regular equation, a squared equals 9, I do want you to write plus or minus 3. So we found what a is. Let's write them the final answer, okay? So the equation is y equals log base 3 of x. So that's the answer, y equals log base 3 of x. And we found that by rewriting the logarithmic form into an exponential form. Yeah, this is a very fun problem to think about. And I know you're going to see some of these problems on your Alex homework, okay? All right, now, enough of graphing. But when you graph, you do know that the range of a logarithmic function is always all real, but domain always changes, right? Domain without any horizontal translation is going to be from 0 to positive infinity, right? But what if we move it to the right or left a little bit? Now, I'm giving you some crazy looking functions here. And just so that I can review solving polynomial inequalities, which were tested in Unit 2. But here's how you do it. What you need is the argument. Let me write that. Maybe I can move this over there. Whenever you're asked to find the domain of a logarithmic function, remember the horizontal translation, how many you move to the right, how many you move to the left, that has to do with the domain, right? And that happens for the number being added or number being subtracted inside. And you know what I mean by inside. When we talk about the transformation rules, whatever we add or subtract to the outside, those take care of that vertical translation. But if you add or subtract the number inside, then it moves it right or left. So what I want you to, well, in short, I want you to use this rule, okay? If I'm asking you to find the domain of a logarithmic function, set the argument simply greater than 0. Do not say it is greater than or equal to 0. It has to be greater than 0. Because remember, domain of a regular logarithmic function is from 0 to positive infinity, right? So it cannot be equal to 0. It has to be greater than 0. So argument, what's the argument here? Highlight what's inside. It's 8 minus 2x. And for this one, it's 25 minus x squared. That's going to be a crazy one. And for this one, what's the argument? Oh, it's the entire square root of 2x minus 3. And then for this one, negative 5 over x plus 3. We're going to set those highlighted arguments greater than 0 to solve for the domain. Now, the first one is pretty easy. Let's set up 8 minus 2x is greater than 0. Let's solve this inequality. It's just a linear inequality. Subtract 8 from both sides. You get negative 2x is greater than negative 8. Now remember that we're solving inequality. So if you divide both sides by a negative number or multiply by a negative number, remember to flip the sign. So x is less than positive 4. So if you write this in interval notation, I know some of us, like myself, I like to sketch a graph real quick before I go from inequality to interval notation. But this is going to negative infinity to the left and 4 to the right. So that's the domain of f of x, the first function. So that's what you're going to have to do. First, set the argument greater than 0, because that's what used to be just x in a function that is not translated to the right or left. All right, let's try this one. This one's a little bit hard. 25 minus x squared is greater than 0. Now, let me show you what you're not supposed to do, okay? You subtract 25 from both sides. Don't copy this because this is not good math so far. Minus x squared is greater than negative 25. And you say you're going to divide both sides by negative 1. And then you say x squared is less than 25. And then you take square root of both. We don't want to do that. Remember how you learn how to solve polynomial inequalities. Factor this. Factor the left side. If you factor the left side, you will get 5 minus x and 5 plus x. Now, you need to find the boundary points. X equals 5 or x equals negative 5, right? And then what you have to do is plot them on a number line. And I had to take away some points on many of our exams. If you didn't show your work, why certain intervals come out to be positive or negative. Do you remember though why I'm drawing a open circle? It's open circle because it's simply greater than 0. Now, let's test these 3 intervals. Okay, let's test these 3 intervals. I'll use a different color. If I plug in a number, by the way, I didn't mean to put negative 5 and negative 5. I meant to put negative 5 and positive 5. Sorry. All right, let's plug in a number that is to the right side of that. What is a good number to plug in? I'm going to plug in x equals 6 because that's bigger than 5. If I plug in 6 into this, hold on, I'll get 5 minus 6 times 5 plus 6. And if I get the sign, that will be negative times positive 11. So that will be a negative 11. That's a negative number. So this is a negative, or I think I just wrote down a negative symbol. We know that's not the answer interval. Why not? Because we're looking for an interval that is greater than 0. Let me check the other one. But I know you know so much of this math already. You know using the multiplicity of these zeros, which are all odd, by the way, odd multiplicity, is going to cross to the other side because odd multiplicity implies that the graph will cross at that x-intercept. So without really plotting or without really plugging in more numbers, but you know what, let me just do one more just to double check. A good number will be plug in what number? X equals 0, right? So that will be 5 minus 0 plus 5 plus 0, which comes out to be 5 times 5. Absolutely positive, right? So use what you already know. You learned so much already. And this multiplicity and whether the graph will cross or bounce at these x-intercept will save us a couple minutes on checking the signs of this interval. But by the way, we found it. We found which interval is greater than 0. Notice they wanted greater than 0, right? So, there we go. The domain of this function, domain is from negative 5 to positive 5. Okay? Now, that's great. And you know what? I'm going to still ask you to show me work because I know what's available out there. You see with my little iPad, I downloaded this app. I can type in y equals, what was the function? Log base, oh gosh, my memories, you know. Give me 1 second, guys. Log base, no base, it's common log, 25 minus x. I'm gonna do this math way to see I know, you know, this is on some of our devices. 25 minus x squared. And you know, it was so cool. And I just said, hey, I pressed this little button. Press the little button. And then I can tell it to find it, hey, to find the domain. And they're going to give me the domain just like that. Negative 5 to 5, positive 5. I know what's out there. I know what's available for you. But I want you to be able to show me the work. You can check the answer, right? But I want you to be able to show me all that work that supports the answer because it's important for you to know how to find these instead of just typing into an online calculator, okay? All right, but that was a good review of polynomial inequality problem. Let's go back and try a couple other, okay? Well, you know the rule. You set the argument square root of 2x minus 3 greater than 0. Let's solve this, okay? I can take square of both sides. Then I'll get 2x minus 3 is greater than 0. Add 3 to both sides and divide by 2. We got that x has to be greater than 3 over 2. Therefore, the domain is 3/2 to positive infinity. Now, that one wasn't too bad, right? That one wasn't too bad at all. Let's do the last domain problem. Ooh, look at this. We got negative 5 over x plus 5, and we know that must be greater than 0. Now let's solve this. And remember how we solve this? Here's the thing though, what we are not allowed to do. We're not allowed to multiply both sides by x plus 5. Here's why, okay? What do you know about x? Like, can x be positive? Can x be negative? So you're thinking, can x be negative 7? And the answer is probably yes. I mean, who knows? I don't know. And maybe negative 7. So if x is negative 7, what happened? This quantity will be negative. Then we'll be flipping the inequality. So, you know, that's not how we solve rational inequality, right? We learned exactly how to solve rational inequality. We find the zeros of the numerator and zeros of the denominator, right? Can the numerator ever be equal to 0? Can that equal to 0? Negative 5 equals 0? No. We don't have a 0 of a numerator this time. But what we got is we definitely can make the denominator 0. That will be negative 5. Not that we are allowed to make this 0, but negative 5 will be our boundary point, okay? But you know why I left it as a blank circle, open circle, not only because it says x is greater than 0, but because x cannot be equal to negative 5. Otherwise, the function will be undefined. So just a great review of what you and I talked about in the previous unit, solving rational inequality. And after grading Unit 2 exam, I think it's great to review these. So let's go ahead and plug in the points here. Let x equals 0. 0 is bigger than negative 5. I know it's a little bit far to the right, but that's okay. If I plug in 0 in there, what will happen? 0 plus 5, that will be negative 5 over 5, and this is negative. This is negative. All right, if I plug in a number, x equals negative 6, let's see what that sign comes out to be. Negative 5 over negative 6 plus 5, that's negative over negative, and this is positive. Now, we were looking for an interval that is greater than 0. So when we solve this inequality, we get that the domain, we can write the answer now, domain of f is from negative infinity to negative 5. I know you can type this in your Mathway or other calculator and they will just give you the domain. And maybe some of you paid for that account. But you know, I do want you to please, because you don't need to pay for anybody to show your math work, because you're capable of learning this and doing this yourself. So make sure for exam 3, you showed me all these steps if I decide to put one of these on your exam, okay? All right, so that's enough of domain. Not only that we were talking about domain of logarithmic functions, it was a great opportunity for us to review solving polynomial inequality and solving rational inequality. All right, now that leaves us with the very last page, examples 7 and 8. Now this isn't gonna take long, so I'm just gonna go ahead and finish this and we'll talk about the quizzes classwork, okay? All right, example 7. Below is a graph of f of x equal log base 2 of x. We graphed it before. We know how to make this. But, oh, look at that. They want you to translate it. They want you to move it so that it becomes a graph of log base 2, x plus 4, minus 1. So let's talk about this transformation here. Subtracting this 1 will move the graph, how many? Down 1 unit, right? Subtracting 1 outside will shift the graph down 1 unit. What else? Look at this inside part. Adding 4 inside. Which direction will this adding 4 inside shift the graph? This will shift the graph, move 4 to the, what do you think? left. Now, since day 1, maybe like day 2, we started talking about the transformation of function. Then it still applies. We still got to remember this. So I got 1 point they gave me, but it will be better if I have more than 1 point. So I know exactly how to move that point, but let me pick another point, okay? What's another good point that I can use here? Maybe this one right here. And then I will move this one too, okay? That's probably good. That's probably going to be good. Now, they also want you to state the domain, range, and asymptote. We'll do that, but let me first go ahead and graph a new line, okay? Let's graph a new line. So move each point down 1, left 4, okay? Move each point down 1, left 4. And on Alex, when you do the homework, it will be much, much easier, right? Because you're just going to have to click on it, move it down 1 over 4 to the left. Because I'm doing this on a paper, I'm just going to have to, actually move each point to move the curve. All right, let me move now. Down 1 over 4. 1, 2, 3, 4. Here's my first point that I moved. I'm going to plot it right here. Next one, down 1 over 4. 1, 2, 3, 4. Oh, I'm going to have a new y-intercept right there. And then the next one, the last one, down 1 over 4. 1, 2, 3, 4. Oh, it used to be where my second point is. Now, let me go ahead and sketch the graph. It's going to go up that way, right? It's going to go up that way. But remember, the vertical asymptote, the original vertical asymptote, for vertical asymptote of f of x is at x equals 0, right? Let me show you what I mean by that. We had a vertical asymptote right there, right? For the blue graph, the original graph. But listen, we have to shift this entire graph 4 to the left. So what do we know? What do we know? The vertical asymptote, I'll just say VA, of the new function g of x is at, we shifted 4 to the left. So the new asymptote better be at -4. So I'm going to go ahead and just shift the graph, the asymptote over here at -4. So what that means is our new graph, our green graph, is not allowed to cross that line. So it's just going to drop down its tail as it gets really, really close to that vertical asymptote, but it's not allowed to cross it, because the vertical asymptote of x equals 0 got shifted 4 to the left. Now, that's a great graph for us to talk about the domain and range. So domain and the range. Because we shifted the graph 4 to the left, the domain is not anymore 0 to positive infinity. It's going to be from -4 to positive infinity. But then the range, as you can see, is going down forever to that left tail. And it's going to go up forever to the right side. So the range is going to be from -infinity to positive infinity. Guys, I'm only showing you like one example. I would love to show you more and more in one. But I'm going to ask you to please do the practice problems, because it will take some practice for you to actually master these ideas, okay? All right, the very last one. I just had to put one at least, an application problem. It's a very short one. All right, a certain strain of bacteria divides every 3 hours. If a colony is started with 50 bacteria, and then time t required for colony to grow to n bacteria is given by, thank goodness, they gave us a function that we can use. It will be a completely different example, right, or problem if we didn't have this equation to use. But we got it. We're just going to use it. Find time required. Find t. They want you to find t. Find time required for colony to grow to million bacteria. Now remember, n stands for bacteria, right? They want million bacteria. So you're going to plug in n equals 1 million. Okay, you ready? Let's find t. T equals 3 times log of 1 million divided by 50 over log 2. Now, guys, I just said log. What is the base of these two log expressions that we just wrote down? Base is hidden, right? Base is 10. These are common logs, okay? So we can simplify this and we can type this into our calculator. And, you know, we can do this. We can simplify this as far as we can without the help of a calculator. Eventually, we will try to type this in. But next lesson, 3.4, I believe, I'm going to get to talk about some of the cool log properties. So for right now, it's okay if we type this into our scientific or graphing calculator to just get the answer value, okay? So second quit. I'm going to go ahead and type this in. So type in 3, open parenthesis. In the numerator, type in log. And the log, the argument will also have a fraction of 1 million, 1, 2, 3, 4, 5, 6, divided by 50. And I'm going to go ahead and close just one parenthesis there. And the denominator is simply log 2. I am done typing the expression. If I hit enter, I get that it takes about 42. I forgot the unit of the time, but let me go back to the paper and write it down. This came out to be approximately, didn't say anything about rounding, but you should probably be careful when you're typing your answers in your online homework because they may be particular about those roundings. But what I got was 42.863, and this was time. Was the unit in minutes, hours, days, years? Let's see. T was in, oh my goodness, hours. So if you start with only 50 bacteria, it's going to take only 42 hours. It's going to take only 42 hours for them to grow into million bacteria. So, we better wash our hands. So hopefully you guys are doing okay in this you know, crazy times. Talking about bacteria and virus. But that's it for lesson 3.3. So I really miss you in class because it will go much better. I get to interact with you. So let's try, guys. Let's try to have a Zoom class before end of the semester. The reason I'm pre-recording the lessons is because I've got emails from students saying that they cannot make the regular time of the class because they have to pick up another shift or things like that. But if we can still have a Zoom meeting from 12:30 to, you know, our regular class time, and I can record that session. So you don't have to feel bad about missing that, you know, synchronous class time. But I hope this pre-recorded asynchronous class is going okay for you. But then I'm also using our class time as an individual Zoom office hour because some of you are coming to me during that time to ask questions. So, well, I hope you're doing good. Write me an email if you ever want to talk about anything else, okay? All right. Now, what you're going to do for me is you're going to go to Canvas. And I posted this on Canvas already. I'm just going to open up my Tuesday, Thursday class because I know it's in that class too. But if you're in Monday, Wednesday, you also have this available. Logarithmic functions quizzes. You click on this link that I posted and it will give you a quizzes. You can type out your name, but please use your real name. And first and last name will be great so that I know who I should give the credit to, right? You start the game. I'm going to start. To save your progress, you will need a free account. You really don't need to make a free account. I just need you to use your name so that I can give you the grade. And it's gonna start. And just 20 quick questions on what we just talked about. Write in the exponential form. Well, that's 2 to the negative third power equals 1 over 8. Yay! So just like that, you will do these quizzes for me. And you can do this unlimited times. Now, they want you to find the domain of this. Now, this one, remember, it will be helpful to write some things on your paper. You will set up x plus 3 is greater than 0, and you solve for x. So you do this, you complete this quizzes, and oh, looks like Jalen's playing this with me. But I'm gonna get the results after the due date, and I will transfer the grade into Canvas. But you just, if you want to do more than one attempt, just use the same name. I think I set it up so that it will record the highest score. But this is going to be the classwork for 3.3. But I will be back and ask you to do some work on a piece of paper, because I want to see, I always want to see your handwritten work. I'll post this on Canvas too, but with us having only what, less than 5 weeks left, we only have like 4 weeks left. If you are willing to do any makeup work from these past weeks, I'm open. Okay, please email me. At this point, we're about improving the grades, making up the assignments so that you can get the highest grade that you can. And also think about whether you're going to apply for the ABC, the letter grading system, or just stay with the default, the pass-fail. Nobody's failing this semester. Everybody's getting either WC, withdrawal, COVID. But, if you have any questions on those grading systems, feel free to email me.